I was incredibly shy when I started out being an engineer. I really was a nerd, and I had appalling people skills. But I was put in situations where I had to do something about that.
Welcome to another episode of the Being an Engineer podcast. Today we are excited to host Professor James Trevelyan, a renowned engineer whose career spans significant contributions to both academia and industry. James's work has profoundly impacted practical engineering applications and education, notably in areas of robotics and automation. His extensive research and development projects have not only pioneered technological advancements, but have also provided critical insights into engineering practice. With a focus on enhancing the utility of engineering work and its recognition in society, James offers invaluable perspectives on navigating and succeeding in the world of engineering. James, thank you so much for being with us on the show today.
Pleasure, Aaron. Lovely to meet you.
Well, James, can you tell me a little bit about how you decided to become an engineer?
I never really thought of anything else, Aaron. From as early as I can remember, I was playing with model trains, taking things apart. I definitely have always been inclined towards mechanical engineering. But several times in my life, I have been rudely dragged into other areas of engineering out of necessity as well. So yeah, it really wasn't a decision. It was something that I just, I guess, channeled myself into right from the very start.
Yeah. In your genes, in your genetics, huh? Just part of who you are.
Somewhere there. Yeah. It's not common in my family. My family, if anything, tend to be, progressive politicians, somewhat naive to the realities of politics, and also quite a few religious personalities and writers.
Interesting. Okay.
So I did follow some of my relatives in writing some books.
That's right, and we'll talk about one of them in particular, the making of an expert engineer. Before we get into that, can you share a little bit about? You've had an extensive career in academia, but you've also been involved in industry. What do you think is one of the keys to effective collaboration between academic research and industry implementation?
I think that, my career has essentially been one where I've had a foot in both camps pretty much all the time. So that's made it possible for me to shift between one and the other reasonably easily. One of the things I've discovered from my research is that academia tends to be an anti-collaborative environment. When you're a student, collaboration is generally regarded as cheating. And academics are tend to be the most successful of the students in adapting to that culture. So it's actually really difficult to get effective collaboration in most academic environments. And my research suggests that starts with the assessment process, because when you think about it in the university, the way that you get grades, which is essentially how your contributions are valued, is that you sit down in an examination hall or somewhere maybe in a quiet spot with a laptop to write your assignment. And when I was teaching, and I tried to introduce students to the realities of engineering, which I was not only exposed to professionally through my life, but also, of course, exposed through my research, which drew my attention to lots of things I'd taken for granted and never taken much notice of when I was actually practicing an engineer. I would put the students through an exercise where they not only had to collaborate with others in a small group, they also had to collaborate between the groups. And, some of the students came to me bitterly resentful, saying things like, why the F should my grades suffer just because those guys are too lazy? And my response would be, well, welcome to the real world of engineering.
Exactly. And life in general.
But one one of the things that struck me was the emotional resentment to this idea of collaborating. And it took me some time to figure out really what was going on until I realized that there's something we call in education the hidden curriculum. It is the messages that we send to students non-verbally. We never actually explain it. And so one of the things that we do, a very powerful message for students, is that you get grades by sitting down on your own and working on your own, and you don't pay attention to what other people are doing. And this message, unfortunately, goes with them into their working lives and causes great difficulty for many. I was just lucky I was put into situations where I had to adapt into a more collaborative culture, but it's much easier for some people than others.
Have you found that this is more true in the past 15, 20 years with the rise of social media versus before we were so connected yet paradoxically alone?
There is a discussion amongst economists called the productivity puzzle. And essentially, economists are trying to explain to each other why global productivity has taken a hit since around 2005. If you look at global productivity, and particularly in wealthy countries, productivity increased by about 2% to 3% a year through the second half of the 20th century and even earlier, although we don't really have much data before the 1950s. And it might be worth remembering what productivity is. It's pretty simple concept. It's the ratio of the goods produced compared with the labor and other inputs required to produce those goods on a grand scale across the whole economy or across an enterprise, an industry, or whatever. And thinking about what happened in 2005 that changed everything so much, to my mind, it was the introduction of the smartphone. In fact, of course, smartphones and other devices have been around beforehand. But when I was working as an engineer in the last century, it sounds like a long time ago, doesn't it? When you wanted to get the attention of other people, you wanted to get some information or whatever, you had the choice. You could send them a letter, you could write a report and send it off, you had to get it typed, and so on and so forth. And, getting an answer would take weeks if you were lucky. So normally what you had to do is actually go and see people or at least call them on the telephone. So it was actually necessity to talk to people. Now, of course, text communication is fast, free, and easy. And interestingly, in the 1950s, psychologists discovered that if you only communicate with text, you undermine trust and undermine collaboration. But that's a lesson we seem to have forgotten. There's some really interesting books written by people like Sherry Turkle, who worked at MIT, and thoroughly recommend those books if you have the chance to look at them. And she has looked at the way that social media and electronic communication has changed the way people interact. And it does give people more of an option to withdraw. So as engineers, since, we still have to produce results, even though people work differently, it's really helpful to understand what's been happening and realize that we do have to adapt and change the way we operate to take this into account. So yes, there's been a huge shift, and I think we're still grappling with the consequences of that shift, and particularly when it comes to things like organizational culture.
I think you're right. I have certainly noticed, even within my own small organization, that, and I would say this is particularly true of the younger engineers, but maybe true to some extent with all of the individuals, that there is almost an unconscious preference towards emailing people. And it drives me crazy, especially when I see an urgent need for something, right? We need to get an answer quickly. A project deadline depends on it, or something like that. And I'll ask the engineer, were you able to get in touch with whoever it is, the vendor, the customer, right, to get this answer? oh yeah, I sent an email. I'm waiting for them to respond. And I want to pull my hair out. Don't send an email when you need a quick answer. Call them, or if they're in the vicinity, go visit them, I'm actually putting together a presentation for engineers about communication. And one of the very first slides is a scale of urgency and the different methods of communication that one should and could use depending on how urgent that communication is. And of course, email is down at the low end of urgency. And then as you increase in urgency, maybe text or direct message. And then at the high end of urgency is in-person visits or a phone call. But I think for whatever reason, probably social media has something to do with it. As a society, we have become less inclined to just talk to people in person or even over the phone.
Yeah, I think that's a very valid observation, and you'll find many people have remarked on that. I had an interesting experience early on in I think it was my academic career. I was asked to consult with a large number of people on a particular issue. And I dreaded this because I thought I really don't want to spend hours and hours and hours collating all their different points of view. So I sent a large number of emails, but I put the important information on which people had to comment. I put it in an attachment to the emails. And out of about 400 emails I sent, I only got 5 replies. So that saved an awful lot of time and effort. So I was deliberately exploiting this reluctance to engage with email in order to reduce the amount of work I had to do.
Great loophole. I love it.
And nobody could complain that they weren't consulted.
That's right. They had the opportunity. They blew it.
That's right. Yes.
Well,
so yeah, it's something that you can exploit, but it's I think definitely you're on the right track. It is hard to encourage people to get on the phone and call. There's a reluctance and so on. But it's once you get over that shyness. I was incredibly shy when I started out being an engineer. I really was a nerd, and I had appalling people skills. But I was put in situations where I had to do something about that. And I got some good training courses and so on and so forth. And so it's important, I think, for young engineers to understand we all develop differently. We all develop at different rates. And, as engineers, we tend to be early developers when it comes to mechanical or mathematical skills, understanding science and so on and so forth. And maybe our interpersonal skills lag behind other people. Not everybody, but definitely I was one of those. But it's something that develops over time. And there's no need to classify yourself as being a nerd or a terrible communicator for the rest of your life. These are skills that are easy to learn.
Terrific point. We all change and grow over time. Who we are today is not necessarily who we're going to be tomorrow.
Thankfully.
Yeah, thankfully. Ask my wife, right? Well, you are joining this conversation with me from Australia right now. And I've never been to Australia, but I have the sense that there are a lot of commonalities culturally between the United States and Australia. But you also have experience working in some countries where culturally and probably in other ways, socioeconomics, etc., things are very different. For example, Pakistan. How has your experience working in countries like Pakistan shaped your approach to engineering and innovation?
Very good question, Aaron. First of all, I would caution you and say that Australian culture is very different to American culture. Just know that and be prepared.
Okay.
But definitely, I think you would be right in saying perhaps there's more in common between Australia and America than there is between, say, Australia and Pakistan. But I'm not quite so sure about that. But definitely, it's first of all, it's refreshing because when you operate in a different culture, you suddenly become much more aware of your own culture and how that's different. So, of course, I had the advantage of marrying a wonderful woman who was born in Pakistan, her family there. And the first thing that you get exposed to there is the amazing hospitality of people. Hospitality is part of the culture. And the difficult part is how to decline hospitality when you either haven't got the time or you need to be somewhere else. But at the same time, as an engineer, I was struck by 2 or 3 things. The first was the amount of rubbish around the place, dirt, rubbish. The place looks run down, and I'm sure many of your listeners who have been to less developed countries would echo that perception. And I'm thinking, surely labor is so cheap here. Why don't, it would be so inexpensive to hire people to clear up the mess. The second was, and this only emerged over time, how expensive it was to do business there. I was involved in a project to develop improved devices to help people clearing landmines in Afghanistan. And, I naturally thought that it would be a great idea to do this work in Pakistan for 2 reasons. One is we could save a lot of money because labor is pretty cheap there. And secondly, we had direct access to the fellows who were actually removing mines in Afghanistan, because at the time they were based in Pakistan, they'd commute because the situation in Afghanistan wasn't particularly conducive for living conditions. There was a war going on there. And I found to my surprise that it was actually a lot cheaper to do the engineering work in Australia when you compared the quality of the results. So I struggled to understand why smart engineers who had been educated at some of the world's best universities struggled to produce results in Pakistan that one could take for granted in a country like Australia or even the US. And yet, Pakistani engineers, Indian engineers, because this is a problem that I soon found is common to lots and lots of countries. Engineers from these countries come to countries like Australia and America, and they do really well. So what's going on here? And, eventually I realized it was something to do with the local culture and the environment. And after 20 years of research, and some of your listeners might wonder why it took so long to figure it out, but it's a really challenging issue. After 20 years, the best way I can summarize this is to explain that engineering essentially has 2 broad activities. One is the application of technical knowledge, and some of it scientific, some of it mathematical, some of it just practically acquired experience. And this knowledge generally works the same everywhere. You need pumps to send water uphill in Pakistan just as much as Australia. And the same pumps will do the same job. But the other side of engineering is, how do you get the results translated into action? Because in engineering, we engineers seldom touch, even often we're not allowed to touch the things that we are responsible for. So we have a huge collaborative undertaking involving lots of people, ranging from the people who provide the finance to the people who get their hands dirty. And so the understanding of what's needed has to permeate the whole organization. And that's the challenging part, because in the cultures that you will find in countries like Pakistan, collaboration is far more difficult. Information doesn't get freely exchanged in the way that you might think it does in a country like the USA, Australia, Europe, Britain, France, and so on. And once you realize that you've got these barriers, you can understand why it's so challenging for the engineers to do things. Now, of course, earlier you were talking about my book, The Making of an Expert Engineer. And almost by accident, I stumbled across engineers who had somehow magically overcome these issues. They were able to produce results which equal to the best in the world in that environment. And yet they couldn't explain how they'd managed to do that. Some of them had been exposed to engineering in developed countries, in Britain, America, and so on, but many had not. And so it was a real puzzle to me to try and understand how it was that these engineers managed to produce these results. It was very easy to identify them once you knew what to look for, because they were paid extraordinarily high salaries. So a typical engineer in India or Pakistan will earn around about a quarter of what an engineer would earn in the US or Australia, in rough terms. These engineers were actually earning more than their counterparts in countries like Australia. And that was because their companies realized that these individuals were so critical to their operations. They wanted to make sure that they would never think of leaving. And so, here was the answer to my puzzle. If only I could understand what it was that they were doing differently. And that's essentially why I wrote the book. It was to understand what they do differently. And it turns out that it's not rocket science. Anybody can learn. And so my hope is that one day engineers in every country in the world will understand that collaboration is something that you have to work through a local culture, and that understanding how that culture works is the key to getting great results in engineering. And the shame of it is that we don't even teach collaboration in engineering schools. It's all technical stuff. And it's assumed that just because students work in groups together, they'll somehow learn to collaborate. When you actually look at what students do as a researcher, you actually find that in spite of the fact that they're working in groups, they're still engaging in anti-collaborative behavior. And it's a real struggle for many companies to turn young engineers around and to get them to collaborate. As engineers, we're often accused of having lousy communication skills. Companies complain that fresh graduates have, poorly developed communication skills. I think what they really mean is that they have poor collaboration skills. And, collaboration is much more complicated than just communication. So here's a whole area which is a big struggle, I think, for engineering schools, because introducing this idea of collaboration does require a culture change in education. And culture change in companies is hard enough. Getting culture change in education is far more difficult.
I wonder if the reason that we don't have better communication or collaboration skills as young engineers is because, for right or wrong, and I think it's for wrong, there's no money in it, right? As an industry, and I think this is changing, but historically, as an engineering industry, we haven't recognized the value of communication, at least to the extent that there's actually money in communication, collaboration, education.
Okay, Aaron, let me talk about another aspect of my research here. There definitely is money in it. And let me explain why. So, in doing essentially, where did I start? So this problem that I was confronted with, why was it so difficult for engineers to collaborate in a country like Pakistan, India? Essentially, that was my starting point. And so I naively thought that if I observed what engineers were really doing there, I would be able to take that knowledge back to Australia and look up from texts what engineers did anywhere in the world, and immediately the differences will be obvious. Well, when I got back to Australia, we started looking for research on what engineers really do. And at the time, the early 2000s, it was really, really hard to find any detailed observations of what engineers really do in their work. Lots of people had studied engineers, but they were more interested in engineers working in teams, or how did engineers do management, and so on and so forth. That very few people had actually asked this question: what's the engineering bit, and how does that work? So I soon realized that we had to answer that question before we could actually start looking at the differences. So that was the first challenge, to answer this question: what do engineers really do in detail? How do they do it? And then we started to notice some interesting patterns. For example, one of my students decided to do a project to understand design checking. And that started because I asked him what he was doing in his summer vacation before the last year of his course. And he said, "Oh, I'm doing design checks." And I said, "But you're working in a company. You are the least experienced, the least knowledgeable person in that company as a student. How come you are doing design checks when that should be the job of the senior engineers?" And he said, "Oh, the senior engineers don't have time to do it, so they asked me to do it instead." So I thought, this is really interesting. And what came out of that was the discovery that, and we think it's almost universal, that engineers have an aversion towards activities like checking and review. And it stems from this idea that the valuable stuff in engineering is design, calculations, that sort of stuff, making progress. And doing design checks takes time, delays the project, generally gets in the way of what many engineers see as real progress. So there is a reluctance to engage with it. And the more we looked at this, the more we realized that we had to answer a question. Well, what do engineers do? And why do they do what they do? And why do they avoid some of the aspects of what would be classified as engineering work? What was it that made engineers so reluctant to engage in checking? And that brought us to the idea of value. So in everything that we do, our instinctive ideas of what creates value drive our instinctive decisions. Think for a moment. You arrive at the office in the morning, you get your computer started, and you see 50 or 100 emails there. What makes you decide which one to open first? You know, there's an instinctive decision-making process there, and psychologists talk about notions of value because, in essence, we are driven by what we think is going to create value for us and sometimes for others. So this idea of value, these instinctive ideas of value become really important. And then what we went on to discover was that there was no understanding in the research literature on how engineers produce commercial or economic value. You know, economists basically have worked on the assumption, or not really assumption, they've deduced that innovation is really important in creating value. This came out of the work of economists in the 1930s, who were confronted with, at that time, a monumental issue. The monumental issue was, would capitalism or communism succeed? You know, this was the time when communism had taken a grip on a large proportion of the world, had certainly captivated large numbers of people, even in Europe and America, who were, you know, had this idea that somehow working people should have much more of a say in what was actually going to happen. So this idea was pitted against capitalism, where essentially the idea was that it was finance and money and economics which would drive success rather than the rule of the working classes. And there was this huge debate amongst economists. Of course, they didn't know what we know now, that at least in economic terms, you know, freedom and the ability to allow the market pressures to decide what's important produce economically a more satisfactory result. Now, many people, of course, would question that, saying, well, we've also got an environmental crisis on our hands. But if you go to countries where there still are traces of the original communism left, you'll soon find that the environmental crisis is much more acute there than it is in countries like Australia and America. But let's all agree we have a major issue on our hands, which we're obviously now trying to do something about. That set aside, what came out of that was that innovation was really important. And consequently now today, you will find lots in the engineering media about entrepreneurship, startup companies, and so on. That's where the prestige is. Now, here's the catch. only about 3% of all engineers are engaged in what you would call real innovation. 97% of engineers, roughly, maybe give or take a few percentage points. The vast majority of engineers are not allowed to innovate. Why? Because the client says, if this hasn't been done before, find me a way that has been done before, because I don't want to be the guinea pig. I don't want to be the enterprise that learns the painful lesson that this was not the right way to do it. I'm sure you've come across this before. But, one of the engineers I interviewed summed it up beautifully. He said, the only 2 times I really enjoyed myself in my career were when the client forgot to ask, has this been done before? So as engineers, we have an instinctive desire to innovate. And most of our clients have an instinctive desire to stop us and say, no, do it this way. So if engineers are not innovating, how then are they creating value? This was the puzzle we had to confront. And here I was helped by some really smart economists who reminded me that there's a very well supported principle in economics that says the value you create is directly related to your earnings. On an average, there's always variation depending on circumstances, but generally, if people are being paid, they must be doing something valuable. And if you just think for a moment, if companies had somehow figured out that engineers don't contribute much value, that they can make more profits by firing their engineers, there'd be very few jobs left for us engineers today. And luckily, that's not the case at all. So we must be doing something that produces value, but the question is what? And what comes out of that analysis is that collaboration is an important driver of economic success. What's the best measure for that? We only have to look at the performance of engineering projects. As engineers, it's rather discomforting to learn that for major projects, and we're talking about projects over $1 billion, the success rate is appalling. Absolutely appalling. In rough terms, 2 out of every 6 major engineering projects manage to produce for the investors a financial return which is at least 50% of what they were promised when the project was approved. All right? Now, that's a pretty low bar for success. What it means is that 4 out of 6 don't even meet that requirement. What's more, 1 in 6 projects, roughly, 1 in 6 projects, the investors lose everything, or practically everything. So there's a major nickel refinery that's about 3 or 4 hours drive away from here, which is a case in point. It cost about $2.5 billion US. The people who developed the refinery eventually managed to sell it for $250 million US to a Canadian company that should have known better. The Canadian company thought they could fix all the issues, and about 6 years later mothballed the whole thing. So it stands there, a few hours drive away, a pile of steel tanks, pipelines, all the stuff that you'll be familiar with, and it's complete write-off. In other words, the investors lost all their money. And unfortunately, this is the rule rather than the exception. So when you look at why these projects fail, almost invariably, the reason is collaboration failures. So what do we get from that? Effective collaboration does produce huge financial returns. That's the important lesson. So if anybody says, look, collaboration is not important financially, just remind them of that. Collaboration failures explain why so many engineering projects fail. And, many times they get dismissed as communication failures, management failures, and so on and so forth. But these projects are managed by engineers. We can't get away from that responsibility. So and interestingly enough, the data on which this is based, collected by companies who actually specialize in looking at the success rates of engineering projects, that data shows that performance is actually getting worse, not better. It's getting worse with time.
So I have some questions for you. First of all, this data is all very fascinating. And the questions that come to mind are, one, can you define the difference between communication and collaboration? And then two, what are some examples of what poor collaboration looks like versus some examples of what very good collaboration looks like? And then three, what are the steps that one should take to become very proficient at collaborating in engineering teams?
Really good questions, Aaron. So to answer your first question, what's the difference between communication and collaboration? Well, you can't have collaboration without communication. So the ability to exchange information, at least, is fundamental for collaboration. So it's the starting point, if you like. The third question you ask is how can you improve in terms of your ability to collaborate? So my suggestion is to start with listening skills. Engineers spend of the order of about 25% of their time listening on the phone, in meetings, casual encounters. And in my experience as an engineer, the most useful information that I have come across almost invariably has been communicated verbally. So being able to accurately remember that information, it has been crucial in my career. Why? Because people are reluctant to transmit written communication or valuable communication in writing because it may not be their job to do that. And, but they understand that you need to have that information, but they don't want to know, they don't want other people to find out that they're the ones that gave you that information. So that's why it's often transmitted verbally. And, you know, sometimes people are just much more willing to give you information in a casual conversation than they are in a formal encounter. So that's the first step is being able to listen and quickly write notes, because people are reluctant to give you valuable information if you've got if your phone is on record. So much the best if you can sit down, write a few notes. And so in my books, I explain how you can do that. It's really unfortunate that listening skills are not taught in universities because we rely so much on verbal communication in teaching. For example, you think about lectures or tutorials, you can get so much more as a student if you can develop listening skills. In my university a few years back, we decided that it would be a really good idea to teach communication skills to all of our students, right across every discipline. So I found myself on a panel of academics and students to figure out how to do that. And at the first meeting, we were all asked, how should we go about this? So all of my academic colleagues talked about standing up, giving a presentation, engaging in debate, writing essays, the traditional forms of academic communication. And I was with my surname starting with T, I was the last to be asked to comment. So I came up, I said, look, I think the really important thing is to teach students to listen. And I could see by the expressions on the faces of my colleagues that they were really startled by this and puzzled. And one of them said, well, why do you need to teach students to listen? Because they sit in lectures all day. So I explained that I actually measure the listening skills of my students. And I found that they listen for the first 3 or 4 minutes of the lecture and then forget pretty much everything else that was said. That aside, the next person to comment was a student. The students were asked to comment after the academics. And when the student started speaking, I thought, oh no, this idea that I've suggested about teaching communication or teaching listening skills is going to die a death here, right here and now. Because the student introduced himself and said, I'm the president of the University Engineers Club, Student Association. And what Professor Trevelyan has said is absolutely true. I have found as a student that my listening skills have seriously degraded through the years of my undergraduate education. And it was only when I started working in a company that I realized how bad my listening skills were. And I thought to myself, if there's one way to kill an idea in an academic discussion, it is for the students to back you up. And I was never asked to another meeting.
That's kind of a sad story.
It's important to understand. I got this from a PhD thesis, a really wonderful PhD thesis about collaboration in the design of the instrumentation system and the electronics for Volvo cars. If anyone's interested, write to me and I'll tell you where to look for this. And the student who wrote it talked about the idea of infrastructures within academic environments. There are structures, there are ways of doing things that are so deeply embedded that you can't change them. You can't even see them because they're taken for granted. And so we have to understand this is why it's really difficult to change things in education. So rather than trying to change the structure, which potentially would make the whole thing crash and burn, much better to think about what you can do in higher education and what you can't do. And how do you find an effective way for students to learn these things outside of the structures that might prevent that? So that's my suggestion. And, this is a place where I think that companies can do a great deal with young engineers. It's been really interesting to observe over the last 20 or 30 years how many companies have abandoned their formal training programs for young engineers. And often because they say we don't know what to teach them. And that's understandable because there really hasn't been, for much of that time, a good body of published research showing what engineers really need to learn. Now that research is there, it's time to rethink this idea. And I think that smart companies can do a lot with young engineers in a short time by recognizing what they need to learn quickly in order to become effective engineers. And definitely listening skills is the place I would start. And that's, of course, in my books.
So I think that earlier I said there's no money in communication. And let me rephrase what I meant by that. I have seen companies pay lots of money for technical training. Sometimes the technical training isn't even very good, but a company hears, technical training, my engineers are technical people. They need to learn and develop these technical skills. Therefore, I will pay this money to have them trained technically. But I have not come across any courses or any companies who seek out communication or listening courses or collaboration training and pay money for their engineers to learn those things. So it seems to me like there's a lack of financial incentive for the folks that might be very good with listening or communication to promote this type of training, because companies, by the way they spend their dollars, are not supporting it. You have written a book about this, which arguably is a form of training. Maybe can you speak a little bit about what I just said about that, whether you agree with it or disagree with it, if you've seen examples that are counter to what I'm suggesting here. And then I'd love to hear from your book, if you're willing to share, what are some of the tactical ways that engineers can improve their listening skills?
Well, first of all, that's a really interesting comment, Aaron, because certainly in Australia, companies do spend a lot of money on teaching professional skills to engineers, including effective collaboration techniques, although I would say that it's definitely could be improved. But here there's an interesting obstacle that engineers themselves do not like these training courses. And young engineers much prefer technical training courses because they say, well, that's what's going to get me ahead in my career. Here we see the influence of their education, and companies know that they have to do something about it. So definitely companies do spend money on, for example, wouldn't necessarily be directly on collaboration, but for example, on training engineers to write good specifications, on contract management, project management, and so on and so forth. So definitely that's a money-making business in Australia. Companies do spend money in this area. I'm just quite surprised that you haven't seen that in the US. That definitely that's a very interesting observation.
I see lots of training for, let's learn GD&T, or let's improve our CAD skills. Project management. I see lots of training for those things. I haven't seen any training for this is how to talk to people in a way that makes them like you and want to be around you and work with you. This is how to, this is when to use phone versus an email. I don't see those courses. I see the technical courses out there.
You will find them in Australia for sure.
That's the solution then. We just need to move to Australia and get trained there and then come back to the US.
Yeah. I mean, it's definitely, it's a much better recognized issue here in Australia, I think. So, where would you start if you don't have access to good training courses? Well, here I have to say my books. There's some very easy to learn methods there. And I would just remind your listeners, that effective collaboration makes a huge difference to engineering results on the ground. Because essentially in my discussions about value, I talk about three activities that are really important in creating engineering value. The first is what I call value creation, which is the act of creating something which is going to deliver value eventually, a design invention, a new way to, it can be something quite mundane, like a new way to package a product so that it actually enhances the experience of the person buying the product. And that might not mean bits of, more plastic. It could mean things like providing really good instruction materials and documentation to an engineering project so that when people receive it, they know how to use it correctly. The second activity is how do you actually deliver that value, and this is where collaboration is really important, because in engineering, most of the time, we've got this huge collaborative enterprise, and the value of what gets delivered to the customer depends on the effective collaboration in countless people across many cases across the world, not just within one country. And then thirdly, really important is the protection of value. And value protection involves activities like sustainment, maintenance, engineering asset management, protecting the value of what our social license to operate, which is basically building trust in the communities in which we operate, that what we're doing is the right thing. Reinvesting in quality of our natural environment, because it's the natural environment that sustains all of us, engineering and everything else. So paying attention to protecting value that's already been created, either by us or by nature, is another really important aspect of value. And so that's what I try and teach my people in my company, Coolsey, where we're producing these cute little air conditioners, which of course arose from my experiences in Pakistan. You said, what did I learn from Pakistan? Well, one was the need for cooling. and not only cooling, but very cost-effective cooling, because there's vast numbers of people who are really struggling with the heat, and conventional air conditioning does not really meet their requirements because they can't afford it. There's too energy intensive. So getting everybody to understand how you create value through effective collaboration and how you deliver value is I think the starting point. And that's in my most recent book, Learning Engineering Practice. And there's a free publication on my blog, which talks about how you generate value as an engineer. So I'd say those are the starting points, because everything you do as an engineer ultimately is driven by the perceptions of the clients in how you create effective value.
Yes. I think that there is this notion amongst, let's call it, the purest engineer in all of us, where we just want to do the engineering work, and we want to do the engineering work really, really well. We want it to be perfect, when in an ideal world, that would be great. But in the real world, our engineering is driven by business objectives. And if we're not able to meet and support those objectives with our engineering, then we have failed as at least employees of that organization. I know that I've worked with engineers who do exceptionally good work. The quality that they produce is extraordinarily high, but it takes a long, long time to do that work. And in many instances, we don't need perfect work. We need good enough work that gets done quickly. It almost sounds crass to say it that way, but the realities of running an engineering business dictate oftentimes good enough, but quick, rather than perfect, but it takes a long time. Any comments, whether you're in agreement or disagreement with those thoughts?
Look, I'm just, there's a side of my character which is just like the engineer you described. I love spending time to get things right. And so what I've learned in my career is that when you are getting things right in a way that generates lots of value for the client, they'll give you the time and the money to do it, right? You will enjoy yourself much more. So the key thing is to understand where your work starts to create really significant value, and then no one will care how long you take because they know it's going to be worthwhile in the end. So that's the lesson I learned. I was very lucky to learn very early on in my career. I worked on a project to create robots for shearing sheep in Australia. In Australia, we don't these days have quite as many sheep as we used to, but definitely getting the wool off sheep's backs is a really arduous task. And so I was confronted with this idea that, maybe we could develop robots for shearing sheep. And my instinctive reaction was, don't be ridiculous. Find me a farmer that's going to pay $500,000 or $1 million for a robot to shear sheep. So the professor of engineering at the time, he was somewhat more enlightened than I was then. And he took me to a couple of farms and we looked at these huge harvesting machines that they use for harvesting wheat. And he said, that's $1 million sitting in the shed. And it sits in the shed like that for all but 3 weeks of the whole year. And I suddenly thought to myself, okay, maybe farmers could afford a sheep shearing robot. So that was, if you like, that opened my eyes. And knowing that this was an issue which farmers were really agitated about, and understanding that they were prepared to put a lot of money in to find solutions over a long period of time, I really enjoyed myself for the next 10 years, knowing that there was no shortage of money to solve this problem. Now, the intriguing thing is that those sheep shearing robots have, they still don't exist. They're still not shearing sheep in shearing sheds. But the videotape, or the video of our robot shearing a sheep on YouTube, easy to find. Just look for robot sheep shearing. That has modified the behavior of shearers. It was shearers demanding enormous pay rises of the order of 100 to 150% in the 1970s, which motivated the farmers to do something. And that's what got the project started. Since that robot has been demonstrated, the shearers have never asked for a pay rise that wasn't justified by increases in the cost of living.
Fascinating.
And so that change in behavior is what the change in behavior is the reward for the wool industry, and not the actual robots themselves. So that's a really interesting, lesson that sometimes you develop technology to change the behavior of people, and that actually commercializing the product is not an important endpoint.
That is fascinating. Wow. Well, James, I know we're coming up on time, or perhaps even a little bit over at this point. Do you have time for one more question?
Yeah, of course. Yes.
Okay. All right. We've kind of touched on a variety of things already that are likely good candidate answers to this question, but I'll just ask it a little more directly now. What is one thing that you've done or discovered in your research to accelerate the speed of engineering? I know earlier you talked about senior engineers doing design checks as opposed to junior engineers. And of course, we've talked quite a bit about collaboration. What else comes to mind in terms of accelerating the speed of engineering, and the more detailed, specific, tactical you can get about your response, I think the more valuable it will be to those who are listening.
Thank you, Aaron, for asking that question. And it's one I've given quite a bit of thought to. So I'm going to give your listeners, an example from my experience in developing our little Coolsey air conditioners. One of the things that I've learned is that computational fluid mechanics has its limits. And the most useful way that I have found to speed up engineering development with our little air conditioners is to do simple experiments with instrumentation that when I started as an engineer was hideously expensive, but is now very inexpensive, easily purchased, accurate temperature measurement for a start, and get engineers to do these simple experiments, simple measurements, because when engineers confront the, if you like, ground truth, that's when perceptions start to shift. So, for example, when I took a prototype to a factory in China and asked them to copy my design, I said, just produce 50 copies. I want to see if this is going to work in Pakistan. And I took it to a factory which were professional copycats. Ethical copycats in the sense that they would replicate designs as an OEM manufacturer for companies like us. So these engineers set about producing what they thought was a replica of my little air conditioner, tiny air conditioner, easily portable. And before I came to the factory to inspect the results, they said, your machine doesn't really work very well. It hasn't really performed really well in our tests. So when I arrived at the factory, I was a little bit concerned. And they had my prototype there. They had their copy. And they had tested their copy in their very elaborate testing laboratory. And they produced results which show that it didn't really work terribly well at all. I wasn't interested in looking at their expensive thermodynamic testing lab. I had 2 or 3 thermocouples and a piece of cotton thread, which I could use to evaluate air velocity and air direction, turbulence, and so on. And I put my instrumentation on my prototype, and I put the same instrumentation on their prototype, and I said, well, there's your answer. My prototype performed about 60, 70% better. And it was quite obvious by looking at these thermocouple instruments, which produced a temperature, the little $10 instruments that you can buy on Alibaba. And they looked at me in astonishment and they said, clearly we've done something wrong. And so it was, if you like, the ability to demonstrate performance through simple instrumentation. That's what really changed their perceptions.
That's wonderful.
So think of the simplest way you can do a test. I had a young engineer with me just the other day, and he was struggling to understand why the temperature of the tubes in an air conditioning heat exchanger would be the same from top to bottom. He thought, well, it'll be coldest at one end and hottest at the other end, and there'll be each tube will be a little bit warmer than the next. And I said, okay, do this experiment. Take this thermocouple probe, get a glass, fill it with ice cubes, put water in the glass, and put your thermocouple probe right in the middle of the glass and observe the temperature as the ice melts. And of course, what he observed was that the temperature in the water was 0 degrees Celsius, 32 degrees Fahrenheit, until all the ice had melted because of the latent heat of the phase change from solid to liquid. And when he came back, he said, of course, now it's obvious. Now I can really understand. But having been through my physics education, I was struggling to figure out what it would be. But now that I've done the experiment and I can see it with my own eyes, now I understand.
Yeah.
So that's my suggestion. Get people to do simple experiments just to learn.
Great. Well, James, thank you so much for spending some time here on the Being an Engineer podcast. I really, really enjoyed hearing about your research and some of the conclusions that you've come to. Certainly recommend your books, and I will include links in the show notes to those books. Anything else that we haven't covered that you think would be important to share before we sign off?
Well, please put a link to our little air conditioners as well. I'll make sure I'll send that to you so that people can look at them.
Absolutely.
These, I think, have the potential to transform the world. And it's been a really fascinating exercise to come up with something so simple. In engineering, simplicity is undervalued often. But, if you do come up with simple solutions, they can be incredibly effective commercially.
Yes, I will second that. I know that we, as engineers in general, the temptation to make something complicated is high because complicated is fun. Complicated is intriguing and sexy. And so oftentimes we go down these rabbit holes, maybe not even realizing consciously that we're designing something that's overly complex. And I've been there myself, especially as a younger engineer. So I certainly support that statement that you made. Well, thank you again so much for being on the show. How can folks get in touch with you?
LinkedIn, email works. Despite what I said, if you send an email to my University of Western Australia contact, I'm easily found on the internet. Happy to engage and help when I can.
Terrific. Okay. Well, thank you so much again, James, for being on the podcast.
Pleasure. All the best, Aaron.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.